If you don't need them, you make sure that the opening and closing curly brackets are there so that you don't run into basic pitfalls in any that you might have in any language. Loops, again, and like with conditionals, the basic for loops and the basic while loops are also both supported. For loops are supported, and I'll just go over here to my IDE Eclipse over here, and let's just write a really simple for loop to count from 1 to 10. So for int I equals 0, I is less than equal, or less than or equal to 10. Actually, if we want to count 1 to 10, then we should start it at 1. I plus plus. Right? So a couple of things before I actually print anything. You'll note that Java supports loop scoped variable declarations. So in other words, this variable here, I, only exists inside that for loop. After it, if I wanted to do something with it, like I is equal to 10, if I try to do something else with it after the loop, it doesn't exist there anymore because it has been scoped to the loop itself. And you can see right here that it's giving me a compiler error that it has no idea what the variable I is. That's because it is created for this for loop and it only exists for this for loop. After the for loop, it's gone. It no longer exists. All right? In general, for any variable, you want to make sure that the scope is as limited as possible, that you only declare it where you need it and only where you need it, instead of, the worst of that would be global variables, where it's available everywhere in your entire code. Globals are evil. Don't do them. Right? So let's go ahead and just print it out, system.out.println. I won't go printf, I'll just go ahead and go println. Right? And this will be 1, 2, 3, 4. We also have support for the increment operator. I++ simply adds 1 to the variable I. It does so at the end of a for loop, just like any traditional for loop it works. So let me go ahead and run this and see that it counts from 1, 2, 3, 4, all the way up to 10. At which point it is incremented to 11. You break out of this loop, and of course I no longer exists. So if I tried to print it out here, then it would be a compiler error. Right? It doesn't know anything about the variable I because it's been scoped to that for loop. We can do the same thing with a while loop. Right? While int I equals 1 is not going to work in this case. You don't have loop scoped variable declarations with while loops. Most programming language, I can't think of a programming language that actually supports that. So in contrast, what we're going to have to do is we're going to have to declare it and initialize it outside before the loop begins. Then we've got a while condition. While I is less than or equal to 10, I will go ahead and system.out.println print it. Okay. Let me go ahead and run this. Predict though, what's going to happen? Is this going to be good code? I've got an initialization. The three parts of a loop are initialization, continuation, that you're going to continue while I is less than or equal to 10. But the third one, the increment that we have up here in a for loop as the third thing, I didn't write it. Right? So let's go ahead and run it. And what are you going to get? 1, 1, 1, 1, 1, 1. It's stuck in an infinite loop. I did this intentionally because eventually you might write code that is going to be stuck in an infinite loop. If you were at the command line, of course, you would go Control C to kill it or something like that. But if you're in an IDE, well, if you started this entire process with the play button up here, how do you stop the entire process? With this stop button down here. Once you've stopped it, you can clear it out, clear out the console, and okay, I need to go back to the drawing board here. What's wrong? Well, I need to make progress towards that terminating condition, I++. Right? What if I did it up here first? What is this going to print out? Let me go ahead and print out system.out.println. I'll print a bunch of double lines here, equal signs, so that I can get this nice and formatted so we can tell the difference between these two. What's it going to print? What's the first thing it's going to print? 2. Right? And why is that? By the way, if you want to focus on something, you can always double-click on a tab, and it'll give you the entire focus there. And then to go back and restore it, double-click on it again. You may eventually, oh, oops, I'm going to go ahead and close this console, and I can't show it to you because it's appearing on my other screen here. But you can go up to, I believe, Navigate or Project or View or something like that and restore any of these tabs. Let me go ahead and expand it out again. And was your prediction correct? Yeah, it started at 2. On the last one, it was 11. Why was that? So it starts out at 2. Why? Because we initialize it to 1. Before we print it out, we increment it. Right? So it's going to end up being 2 for the first one, then 3, 4, 5, 6. Why does it print all the way up to the 11? I is less than or equal to 10. We come in, we increment it, so now it's 11, and then we print it. Right? If you want it to emulate what we did with the for loop, then that needs to occur at the end of the loop, the last thing that you do, because that's how it works in a for loop. I is only incremented at the end of the loop. Okay? Not at the beginning, not in somewhere in the middle, but at the end. Okay? All right, so those are 2 basic loops. Let me go ahead and cut and paste this so that you have it in the notes. For loops are supported as well as while loops. Right? And this is Java. Cut, paste that, and you'll have it in the notes. Okay? But there's also another type of loop in Java. Probably one that you're not familiar if you're coming if you're coming from, like, say, a C background. Unfortunately, Java has misnamed it. They call it an enhanced for loop. Right? In other words, what's its real name? It's a for each loop. But it doesn't use the keyword for each. Now, to demonstrate this, I'm going to have to dive a little bit ahead to our next topic, which we're going to do right after this. So it's not that much of a preview. But let's do, I'm going to give you an array. Int ARR is equal to, now this is an array declaration and assignment at the same time. Let's go ahead and put in the first few primes here. 7, 11, 13, what's the next prime? 17. How many is that? 1, 2, 3, 4, 5, 6, 7. Did I specify the size of the array over here to have to be 7? Nope. In fact, in Java, it's not even going to let me do that. Right? You need to use, there's a 50-cent word for this, elision. Right? A shortening of things. It's not an abbreviation. It's an omission of certain things that are understood within the context. That a compiler is dumb, but a compiler can go through and say, oh, 1, 2, 3, 4, 5, 6. You've got 7 things there. So you must mean that you want an array of size 7. I'll go ahead and provide that for you. Okay? So this is a traditional old array that holds integers. Now, if I were to write a traditional for loop to iterate over this, how would it look? For int I equals 0, I is less than 7, I plus plus. Why do we go all the way up to 6, but not 7? Indexes start at 0. Right? So if I've got 7 things there, then 0, 1, 2, 3, 4, 5, 6 is my last number. So I don't want to go up to and including 7. I only want to go up to and stop short by 1 on 7. System.out.println. And how do I get the ith element? Well, erase of I. Right? Indexing using square brackets. Let's go ahead and print this out and see what happens. Save it. There we go. So 2, 3, 5, 7, all the way up to 17. And just to make sure, I'm going to go ahead and, just to reiterate, you can mix as much as you want. You can mix types, you can mix strings, you can mix integers, you can do whatever you want with this stuff. So array element is equal to, and then I'll use the plus sign here, which is string concatenation. You can take one string and combine it, concatenate it to the end of the other string by simply using plus. You can mix types. So the first type there is a string, and then I've got an integer. You can go ahead and concatenate them together, and Java is perfectly happy with that. What happens under the hood is it takes this integer and it converts it to a string representation. 1 and then 7. The ASCII text value is 1 and 7 for the last one. Okay? Run this again, and you can see, once it's saved, proceed. Oh, sorry. I got rid of my plus. I put it at the end for some reason. There we go. There we go. Element is equal to 2, 3, 5, all the way up to 17. Okay? So that's a traditional for loop, but what I was talking about earlier was an enhanced for loop, a for each loop. Now, there is no keyword for each in the Java programming languages. There are some programming languages that have the keyword for each, PHP being one of them. But we're not it's not in Java. So what an enhanced for loop looks like is something like this. For each element, which is of type integer, x, in the collection array, that's how you should read it, then I will go ahead and system.out.println element, or here, all element is equal to, and then plus x. Okay? That's an equivalent loop that will get us the same behavior. But I don't have an extraneous index variable. I didn't declare int I is equal to 0, I is less than 7, I plus plus, etc., etc. Instead, I used an enhanced for loop. For each element x, which is of type integer, in the collection ARR. All right, now I say collection, even though this is an array, this enhanced for loop can be used on a variety of collections, as we'll see by the end of today. That is a colon, right? You do have to provide the value here. And this x is a local variable, or that's not a local, it's a loop scoped variable that changes on each iteration of this. Java takes care of all the boilerplate stuff for you, saying, okay, the first element, then the second element, then the third element, then the fourth element. It's under the hood somewhere. It is indexing a value, and I is 0, and then it increments it to 1, then it increments it to 2, checking to see, are you at the end yet? But if you don't have need of the index variable, then you can use a shorter syntax here for with an enhanced for loop. Right? It's much more convenient in a lot of cases if you don't need the index. Right? In fact, it's preferable and best practice to use an enhanced for loop in a lot of situations that we'll look at later. Right? So an enhanced for loop is simply just basically a for each loop. There we go. And if it were strings, let's do another example here. If I have an array of strings instead, string names is equal to, it's an array, Chris, Joe, Jane, another Chris, and I don't know, Anthony. There we go. Or here's another one. Nolan Arenado. There we go. So a whole bunch of names here, right? I didn't even bother to count them. I forget how many I actually put in that array. I don't have to worry about that if I use an enhanced for loop. Now how would I do it differently here? Instead of a bunch of integers, x, I would have a bunch of strings, right? And instead of x, which is just a generic value for a number, well, it's a string, so I'll call it s, or str in the collection names. But even that, it seems kind of, str, that seems kind of, I mean, short, sure, that's easy to type. But what would you call one thing in a collection of names? What would be a better variable name for this value? Name, right? For each name in names, then go ahead and system.out.println name. Right? You should name things what they are, and this is a name, and so I've got this. Right? There we go. Chris, Joe, Jane, Chris, Anthony, and Nolan. Right? All right. So whatever type you have in your array, you can go ahead and use that type over here. This is not formatting very well, but I'll fix it later on before I commit it. Always make sure that your indentation is consistent. There we go. Okay. So those are enhanced for loops. And implicitly, the entire time we were using arrays. Right? So Java supports traditional arrays. Right? There's no memory management. So technically, no, say, malloc is what you would use from a C background. So instead, to create new dynamic arrays. Now, what I mean by dynamic, remember last semester the difference between a static array and a dynamic array in C? A static array is allocated on the stack, right? And it disappears and goes out of scope when you return from a function call. A dynamic array is allocated on the heap. In Java, there are no static arrays. Local variables are static, but they always point to, for an array, they always point to an array that's been allocated on the heap. So to create new dynamic arrays, use the new keyword. Right? So I'm going to come back over here, and let's create a new array. Again, you don't have static arrays in C. So, for example, doing something like this, right, is illegal. You can't do something like this. You can't create an integer array of size 10 on the stack. You have to create it on the heap. So instead, what I'm going to do is I'm going to say equal. Now, if this were Java, I would call malloc and say how many bytes I need, et cetera, et cetera. But I don't do that in Java. Instead, I use the new keyword. A new integer array of size 10. Or better yet, let's put that into a variable. I want an array of size 10. I'll just go ahead and use that inside there. Right? Those are square brackets on both sides because it's an array. Okay? Now, sometimes you might see some people using, say, this syntax, and if that's how you want to use it, great. Go ahead and use that. The argument for using this syntax is because an array is a type. It has an integer, and it's an array, and here's the name. Keeping these two things together, some people would argue, I'm not one of them, some people would argue that keeping the two types together is necessary because why would you split it out? It's like a split infinitive or something like that. Have a subject over here and then split a bunch of stuff and then split a verb or whatever, part of a verb over here, split it with a bunch of stuff and then the rest of the verb over there. I don't like that. I prefer this one. Why? Well, because that's how you index stuff. The indexing, the square brackets, they always go after the name of the array. So I will prefer this style. Whichever style you want to adopt, that's your business as long as you're consistent about it. Right? And at the end of the day, you're not going to want to use arrays once I show you something else. Okay? But this is an array. This is how you create an array, and then you can start indexing stuff. You can go ahead and go array sub 0 is equal to 42. And where's the last one in this, by the way? Where's the last? If I set the first one equal to 42, I want to set the last one equal to 101. Where's the last one? What index is the last one at? 9. What's another way that I could do that, though? N minus 1, right? Which 10 is, n is 10, so minus 1 will get me 9. Let's go ahead and print it out. For int I equals 0, I is typing. But I do want to go ahead and show this to you. How do I get the size of the array? Well, in C, you would always put it into a variable, right? And because you need to do your own bookkeeping. I could do that here because I did put it into a variable. I is equal to n, or I is less than n, I plus plus, and then system dot out, dot println I. Right? This will work. This will run. Before I show you a better way, though, or a little bit better way, tell me, what's it going to print? The first one is 42. The last one is 101. What about all the things in between? If this were C, what would it be, by the way? Potential garbage, big question mark. In Java, it is never garbage. In Java, there is a default value. What do you think that default value is? 0. Right. Save, yes. Oops. Oh, duh. I'm not printing I. Array sub I. There we go. There. The first one is 42. Everything in between, because I never set it, is simply going to take on the default value of 0. And then the last one is 101. What if I didn't do... In Java, you don't have to do your own bookkeeping. What if I didn't do it? What if I didn't have this n here? What if I just put in 10 and then I got rid of the variable n here? Well, I couldn't do this anymore. But I also wouldn't... I'd lose how big the array is. Java keeps track of that in what's called a property. So here's my array, and if I go dot length, if I spell it right, that tells me how big the array is. Let me go ahead and run that and show you. And again, the same thing, 42 through 101. This is called a property, so you don't have to do your own bookkeeping. Once an array is created, this value here, 10, is stored in this property, and you can access that property. You can't change that property, because once it's created, you can't take an array and make it grow. You can't take an array and make it shrink. It's always going to be of size. Memory allocated is always going to be 10 times however many bytes it takes to hold an integer. Right? What would it look like if we did doubles instead? Double BR is equal to new int 10? Nope, compiler error. Why? Thing on the left-hand side is an array of doubles, each one being 8 bytes. The thing on the right-hand side, that's an integer. You can't do that. So, double. Right? What about a new string? A string scr is equal to new string. Now you can hold 10 strings if you want to. Okay? That's all well and good. And if you're coming from a C background, this looks like a marked improvement. You don't have your own bookkeeping. You don't have in C. If you were to allocate a dynamic array using malloc, eventually at the end, what would you have to do with it? What would I do here in C at the end? I would free each one of these things up. Obviously, there's no free in Java because there's no memory management. It takes care of it for me, right? There's no size of. The compiler already knows how big each thing is, right? But even so, I mean, it looks like a vast improvement over C, but at the end of the day, don't use arrays. Right? There are much better things in Java. It's called dynamic collections. Right? So plain old arrays suck. Right? Instead, prefer to use dynamic collections, such as a list, or a set, or even better yet, something really, really cool that once you start using it, once you get used to using it, you will never go back to anything else. A map. Right? So for the first one, let me come back over here to my IDE, and let me go ahead and create a list. Before we had an array of integers. So what I'm going to do is I'm going to go ahead and have a list of integers instead. Well, not integers, but integer, right? And I'll call it numbers. Right? I'll make it an array list, integer. There we go. And I'm going to have to import this stuff. This is not part of the standard java.lang package. Instead, it's located in another package. If I hover over this, you'll see, once I put it up here, java.util. There are a whole bunch of collections in here that are super useful and get a lot of stuff done. Remember, one of the themes of this course is that smart data structures and dumb code are a lot better than the other way around. All those smart data structures are in the collections library up here in Java util. Util being short for utilities. Right? An array list is one of them. List is basically an interface. For now, just understand that this is more generic, this is more general than an array list. You can also have linked lists and a couple of other types of lists, but I will make sure we'll cover that when we get to it. Okay? Why is this nice? This is nice because, did I say how big it was? With an array, I said that this is an array of size 10. Did I say that this is a list of size 10? No, instead, what did I say? I said that this is a list that holds integers. That Langle-Wrangle, that less than and greater than, I call those Langle-Wrangle because it's from LaTeX, and that's a parameterization. If I can add numbers to this now, and it dynamically grows automatically for me. I don't have to worry about, is the index out of bounds, or I do have to worry about that eventually, but I don't have to worry about, is this big enough to hold what I want, right? Once I've filled it up, once I've filled up in a traditional array, I can go no further, right? But this one, I can put whatever I want in and as much as I want in. Numbers dot add 10. That adds 10 to the collection. If I want, I can add 20 and then 30. So if I print this out and take a look at it, what should it look like? I'll print the entire list out. Right? This is from last time. What should it print? 10, 20, and 30. It always adds to the end of the list. Okay, great. What if I wanted to add to the beginning of the list? Numbers.add. Right? Well, if I added 40, then that would just add it to the end of the list. But I don't want to just add 40. I want to add it to the front of the list. So I've got 10, 20, and 30. What I want to do is I want to insert 40 at the beginning and shift everything down. So at what index would you want to put it if you wanted to put it at the beginning? 0. Add at index 0 the value 40. And then let's print it out again. So now what should it be? Since I added it at the beginning, it should be 40. Nothing was gotten rid of. Nothing was replaced. Everything shifted automatically down for me. 10, 20, and 30. So 40, 10, 20, and 30. Right? You can continue to add as much as you want. It will dynamically grow, and you don't have to worry about those details. Eventually, if you take things out, right? Let's go ahead and take out the last element, numbers dot remove the element at what's the last one? Where's the last index in this case? If I've got 4 elements, this is going to be 0, 1, 2, 3. So if I remove the thing at the last index and print it out again, then I have 40, 10, and 20. It'll dynamically shrink as well so that it doesn't waste memory. Okay? What if I wanted to remove the last element and I didn't want to have to worry, well, I've added 4 things, so the index must be 3. How do I get the size of the element? Or how do I get the size of the list? System.out.println. Size of list is numbers.size. Right? And how big should it be at that point, by the way? Once I've removed the last element? It's 3, because I've got 40, 10, and 20. I removed 30. Okay? Awesome. Right? And in fact, unfortunately you're not going to be able to see it, but there are dozens upon dozens upon dozens of methods that allow you to put stuff in, remove stuff, alter stuff, replace an element at index 5 with this element over here, if you wanted to do that. And the best thing is, it works just like an array did. In fact, this is where we get this stuff. You can use an enhanced for loop. For integer x in numbers, system.out.println, print x. And now I get, numbers, sorry. I get 40, 10, and 20, each one to their own line. Of course, you can also go with a traditional for loop for int I equals 0, I is less than, how do I get the size of it again? Numbers.size, I plus plus. Then I'll go ahead and go with system.out.println, numbers, sub I. It's not an array. You can't do that. So if you want to get the ith element, how could you do that? Dot get I. Right? And you get the exact same behavior as before, 20 or 40, 10, and 20. There was a question? Yeah.
Yeah. So for the syntax for whenever you're using the dynamic collections, does that switch from int to integer?
Correct. So the question was, what about the difference here as I'm using a big I integer? And that's because dynamic collections have to use their wrapper classes. So if this were a double, it'd be a big D double, right? If this were a float, but we're not using floats, it had to be a big F float. But in this case, it's an integer, so you have to use a big I integer. If you don't, that is not proper Java. So if you are coming from, say, maybe a C++ background, or you've seen generics or templates, that is what they're called in C++, you can use primitive lowercase I integers. In Java, you cannot. You have to use the wrapper classes, or for a string, all right, a bunch of names, a list of strings. Right? You can have a list of any types of objects that you want, but they have to be objects. Good question. Okay? Great. That's a list. What about the other one, set? So some of you, a lot of you are taking, say, 235 right now. What do you what is a set? You might not have gotten to sets yet, but what is the difference? What do you think the difference between a set of, say, I'll switch over to strings here, names, and a list is? Order versus unordered. Hash set of strings, right? And what I mean by that is, let's go ahead and add a bunch of names here. Names.add Chris. Names.add Joe. names.add Jane. There we go. And let's go ahead and print it out. System.out.println names. ln names. Of course, I'm going to have to bring these in. It's already brought in hash set. Oh, sorry, new. There we go. And now I'm going to have to hover over this and import this. I'm sure that there's a quick key that you can learn all about it on your own to automatically import everything. But now I've got java.util.set, and a hash set is my implementation here. Over here, it was an array list that was an implementation. Don't worry about that for now. We'll cover that more when we get to object-oriented programming. But I've got Chris, Joe, and Jane. Now, sometime I might get unlucky, and it might actually print it as Chris, Joe, and Jane. But, oh, it didn't. I got lucky. I'm demonstrating the difference between a list and a set. If I add things to a set, it's unordered, right? And so if I print them out, I got Joe, Chris, and then Jane, instead of Chris, Joe, and Jane, the order that I added them in. So the key difference here is that a set, or a Java set, and a mathematical set, is an unordered collection of, and then the other key part about a set is that it's unique elements, right? In other words, no duplicates are allowed. So, to demonstrate that, let me go ahead and try to add Jane in twice. If this were a list, then I would have order. I would have Chris, Joe, and then Jane, Jane. 2 Janes there. But it's a set. So it's unordered, as we already observed, Joe, Chris, and then Jane. But I'm not going to have 2 Janes now. Right? Let's go ahead and run this. It's the same thing as before. Because when I try to add that second Jane, then it says Jane is already in the collection. I don't allow duplicates, so noop, N-O-O-P, or short for no operation. Right? I'm not going to do any. It's already there. I don't need to do anything. It doesn't do anything, but it's silent about it. It didn't throw an exception. It didn't print an error message or a warning or anything like that. It just said, it's already in there. Don't need to do anything. Right? No operation. Right? So there are no duplicates. Well, you might immediately, of course, you can remove stuff. Names.remove the first one at index 0. Right? It's going to compile. It's not going to do anything, though. Let me go ahead and run it and show you. It's going to compile and it's going to run, but it's weird why it does that, and I'll explain that in a second. Right? It didn't remove anything. Okay, well, remove the second one. It didn't do anything. Remove the third one. It didn't do anything. Right? Why? But let me go ahead and remove Chris and see what happens. I'll remove myself. And it worked. Why? So first of all, does this make sense? Remove the first element. That's how I would read that. A set is what again? An unordered collection. Is there a first element? No, there's no second element, there's no last element, etc. It's a set, it's unordered. So you can't go and say remove the first element. You need to say remove this actual element Chris from the list. And that'll work. The reason that this is compiling and executing but not doing anything is something called, it's a historic quirk of Java. That generics were added in Java 5, and they needed to be backwards compatible. So they used raw types, and it's something that we'll get to with object-oriented programming. Don't worry about it for now. When you see this and you say, oh, well, it compiles, it runs, but it doesn't do what I want it to do, just realize it's doing this, that there's a reason for that. And, oh, yeah, I need to remove Chris. I can't remove something at the first element because there is no first element. A set is an unordered collection. Okay? The second thing that you might immediately ask yourself, well, wait, what about getting the ith element? Names.get the first element. If I want the first name, is that going to work? There is no first element. So how do I do a traditional for loop? For int I equals 0, I is less than names.size. Names.size is a thing. How many elements are in the set? I++, and then system.out.println names.getI. Well, this is not going to work, right? even though size is a thing, this is not going to work. Right? Because I can't get the ith element because there is no concept of the ith element. I'm going to preserve this, but I'm going to comment it all out at once. Oh, cool, trick. How did I do that? Now, Mac, it's going to be command and then / once you've selected a block. For Windows users, I'm going to say Alt and then / Control. Okay, Control and then / and you can comment out an entire block. Now, if you were handing this in this way, you definitely get marks off. Don't leave dead code in your final submissions, right? But I can get rid of stuff very conveniently with block commenting like this. Okay? So what's the solution here? How can I iterate over the elements if I don't have a concept of the first one, second one, third one? A for each loop, an enhanced for loop, right? For string s or name in the collection names system.out.println name. I have to use an enhanced for loop, right? There is no way to iterate over a set other than an enhanced for loop. And of course, we can see now Joe and Jane are the only names remaining. Okay? Awesome. Progressively better things. A dynamic collection that will grow. A collection that doesn't allow duplicates, if that's my use case. If I want duplicates, of course, I need to use a list instead. If I don't want duplicates, like unique IDs, unique NUIDs, I want to make sure that I don't have duplicates, I can go ahead and use a set. Right? But even cooler is a map. So what is a map? A map is basically an array on steroids, right? Because you can do anything, right? A map is a key value pair collection, right? Elements can be accessed using a key which maps to a value, right? So for example, let me go ahead and map the typical example that I do is I'll map an integer to a string that represents the way that that you read it. So what I mean by that is let's go ahead and map an integer to strings, not plural like that. And I'll just call it M or my map if you want, right? M whatever, my map. I'll go with this because I'll show you another neat trick here. Is equal to new hash map, capital M, integer mapping to string. Right? There we go. Kind of a long line, right? In Java, I want to say 7, maybe it was 8, I forget. They added some syntactic sugar to this to allow for another, that 50-cent word again, elision. I don't want to have to retype this every single time. The compiler should be smart enough to see that on the left-hand side, I've got a map that maps integers to strings. Why do I have to type that again? Right. There. Some people call that the diamond operator, langle-wrangle. When you put it together, it looks kind of like a diamond. I do not like that name simply because it confuses you with the diamond problem in object-oriented programming that we'll talk about later. All right. So there's a way that you can get away with using a little bit fewer, typing less. Okay. I've got my map. My map. Now I don't add things to my map because I've got actually two things. I need a key that maps to a value. My map will map .add, or sorry, not add, but put. And this is my IDE being overzealous about completion. I will put 10 maps to the string ten. Right, there we go. I can put my map, and I'll just cut paste here. I'll map 20 to the string value 20, right, if I can spell it right. And then, of course, I'll map 30 to 30. Right? And it doesn't have to be 30. It could be foo, right? It can be any string that you want. Right? Now, why did I call this an array on steroids? What is an array? An array is kind of like a map, but extremely restricted. You can only use integer values as keys, and you go 0 up to size -1. Right? This one, you can do whatever you want for keys. You can do whatever you want for values. Right? You can map strings to integers and have the inverse map. You could map strings to other objects. Later on, we'll talk about user-defined objects like, say, creating a student object. You could map an NUID as a string to a student. Right? You could do a lot of really, really cool stuff like this. Right? And once you start using it, once you see the value of a map, you'll never go back to a regular old array. Right? Hopefully, after having seen the dynamic collection so far, you do not use regular old arrays anymore in Java. Any programming language that supports dynamic collections like this, use them. Prefer them over regular old stinky static arrays or stinky dynamic arrays. Right? That's all fine, but what happens when I want to start working with it? System.out.println, my map. You can see that 20 maps to 10, 10 maps to 10, 20 maps to 30, 30 maps to foo by simply running this. And you see these pairs here. 20 maps to the string 20, 10 maps to the string 20, etc. Right? What if you wanted to iterate over it because you wanted all the keys and all the values? Right? Well, iterating. Right? So I can use an enhanced for loop. I could do what's called an entry set, but I'm going to show you something a little bit different. What I want to do is I want to go for each key in the map, my map. So what is each key? Each key is an integer. For each key, integer called key in the value, my map. Now, my map is a collection. It's got a collection of keys, and each one of those keys is mapping to a value, a string value. So what I need to do is I need to get all these keys. I need to get the key set, dot key set. Then I can get the value. Right? String value is equal to my map. Now, how do I get something out of the map? Get. You provide the key, kind of like a list. I want to get the ith element. I will provide the index. But in this case, they're all indexed by whatever you want. In this case, integers. Now I've got the key and I got the value. I'll just go ahead and system.out.println. And I'll say that the key maps to the value. There we go. Run that, and you see that 10 maps to 20, or sorry, 20 maps to 20, 10 maps to 10. And you can see that, that it's not the order that I put it in. So like a set, I'm getting an unordered collection here. With maps, you can impose an ordering. The easiest way is to simply pull out the key set, sort it however you want, and then iterate over that sorted version of it. I'll show you how to do that later on when we talk about sorting. Okay. You can also replace things. So, for example, my map dot put. Now, oops, I don't like that. Put. If I want to overwrite 30, whatever 30 is pointing to, whatever 30 is mapping to, I will rewrite it to bar instead. Right? And then I'll print it out again. Run it. And you see that 30 is now referring to bar instead. Right? You can replace whatever a key is referring to. You can also remove keys. You can search for a value and remove that value. Two keys can point to the same value. So if I want to, I can put in 40 also maps to bar. Right? And so I'll get duplicate values, but you cannot have duplicate keys. Right? When I've said that 30 now points to bar, that overwrote the old 30 pointing to foo instead. But you can have the same key, or different keys, excuse me, mapping to different the same value. Right? Maps, really, really cool. And in fact, once you start using them, once you'll start opening up a whole world of possibilities. That this smart data structure and dumb code is going to be a lot better than trying to do a bunch of bookkeeping and all that stuff that comes with regular old arrays. Okay. All right, questions so far? Maps. Yeah, go ahead.
Can you print the maps in order, like 10, 20, 30?
Nope. What would you, so here's a preview of how you would have to do that. dump the, you can use a different type of map where you can give it a comparator, but I'm not going to go that far. But I'll dump the key set to a list. I don't dump it to a set because a set is unordered, and you can't sort something that's unordered. So I'll dump the key set to a list. Probably asking them about this because you probably want to do something like this in your homework. A list of, now my keys are integers, right? Keys is equal to new array list. Again, using that elision there, I don't have to rewrite that integer, that second integer. And then I can go ahead and do this manually and I'll grab this up here. I'll go ahead and add each one of these things. For each key, I'll add it to the keys.add key. Right? And then I'll go ahead and sort it. So collections.sort key, sort keys. There we go. And just to show you that this is actually sorting it, let me go ahead and print it out. System.out.println keys. Right. Oops. S. There we go. So I dump the keys to a list. I sort it, so I should get 10, 20, 30, 40, and I do. And then what I can do is I can use that sorted list instead of mymap.keyset. So let me go ahead and grab this and do it down here instead of printing it out. And instead of iterating over the original key set, I'll go ahead and iterate over keys. And now this will go 10, 20, 30, and 40, and then print out each one of those in order. 10 maps to 10, 20 maps to 20, 30 and 40 map to bar. Right? So you could dump it to something that is sortable and then sort it. Right? And note all I did here was sort because if you want the reverse, then you're going to have to use a comparator or something else, or dot reverse I think would work too. Right? I'll go ahead and make sure that you've got all of that in the notes. There was another question over there somewhere? Yeah. Which one? Like these? That's just how it prints it. It just prints an equal sign. I don't like it either. A map should be an arrow, right? This thing maps to that thing over there. I would have put it as an equals and then a wrangle, a greater than sign, so that you have this kind of arrow pointing over there, right? But that's how they chose to do it. Right? Instead of maps to, I could have done it like this as well, right? I could have written my own toString function or my own way of printing things out, and that's a lot clearer that this thing is a map. This key is mapping to that value over there. Right? Okay. Again, make sure that I've got all of this now for the notes. And like all the other collections, if you read the documentation, you can really get into it and you can really do some powerful things. There are dozens upon dozens of methods in there that you can use. Right? Those are dynamic data collections. And by the way, let's go ahead and go back and show you one more thing here. That if I have a list of strings, names is equal to new array list. This is true for all the collections. If your types mismatch, it's not going to compile. What I mean by that is names.add. I can add a name, but can I add a number? So that little red line under add is complaining. Why? On line 15, I said that this is a list of strings. You can add all the strings that you want. But when you add something that's not a string, then it's not going to compile for you. Right? This is type checking. That this isn't that you cannot add a number to a list of strings. Right? If you want a list of integers, then you need to create a list of integers so that you could add that integer. Right? So your types must match. Okay. All right. Well, we've been talking a little bit about strings. Let's talk a little bit more about strings. Right? So Java provides a huge standard library of methods to compute and manipulate strings. Right? But remember from last week, when we talked about strings, can you change a string in Java? No, they were called, there's a word for that. If you can't change them. They are immutable, right? But there are plenty of things that you can do with them by creating a new string. If you want to make them all to caps, for example, and I think I pulled it up last time. Let's do the same again here. Java string. There we go. All right, and there are dozens upon dozens of methods here that you can use. Does it contain this other string here? You can concatenate, but why would you do that when you've got the plus operator? Actually, a dirty secret is what happens under the hood is it does something like this. It replaces your plus in the actual Java bytecode with a method call. Let's see, what else could we do? Index of the first character. So if I want to find the first character in there, if I want a substring, find substring. That's the one I'm going to find most useful, maybe. Replace. There we go. Substring, begin index, end index. Right. Let's go ahead and use that. String, my full name is equal to Christopher Michael Burke. All right. There we go. String middle name. Right? Well, I want this one right here. Right? So how can I get that middle name? I can call full name dot substring, beginning at some index though. And for this, I'm going to have to count. What index is this? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it looks like to me. And let me go ahead and print that out. System.out.println middle name. What is this going to print? Michael? Just Michael? Michael Burke, right? It starts at a beginning index and all the way to the end. That's not what I wanted. I just wanted from starting at M all the way to L. Is there something else that will help me? Yes, if I RTM, read the documentation, read the manual. I have a different version here, substring with a beginning index and an end index. Right? So middle name, beginning at 12, and then ending at, how many is it? 1, 2, 3, 4, 5, 6, 7. So 19 away, right? Or 7 away. Let's see what that does. Right? Okay, yep, that got me there. Let me go ahead and add in just a dummy here, a dummy string. There's the end of the line, so that we can see it. Is it actually going to Michael? Right? Yep, it is. Right? Why didn't I go up to, say, 19? Or why didn't I go up to 20? Remember, this is going to be 12, 13, 14, 15, 16, 17, 18. Oh, maybe I should only go up to 18. Right? I only want to include 1, 2, 3, 4, 5, 6, 7 things. And if this is at 12, then this is 13, 14, 15, 16, 17, 18. What's that gonna give me? Micah without the L, right? That's just the vertical stroke there. Why did I have to go up to 19? Let's read the documentation. Returns a new string that is a substring of the string. The substring begins at the specified begin index and extends to the character at end index -1. So it goes 1 short. And that's because of 0 indexing. So the trick here is that the length of the substring is going to be end index minus begin index. So if I've got 7 characters in my middle name, 19 minus 12, 7, that gives me the result I want. Instead of just going up to the index, you need to go 1 more, knowing that it subtracts 1. Right? And that entire process of, I'd really like a way to manipulate a string like this. The first thing that you should do is jump to the documentation. Is there something there that's going to do that for me, or something that does it mostly for me? And then I can go ahead and manipulate it from there and change how it works. Right? And combine a few things. I want a substring, and then I want it all to caps or something like that. Right? Full string dot to uppercase. There we go. I can chain these things along. Here's a string that'll return a new string that's a substring, and then I will make a new string that has all uppercase out of that. Now this will print Michael all uppercased instead. Right? Whatever you want to do, there's probably a method that will get you, do it for you, or at least get you 90% of the way there. Okay? Another common thing that you do with strings is CSV data. String data is equal to Chris, comma, Burke, comma, 1, 2, 3, 4. Maybe that's my NUID. And then I'm in Shore 105. There we go. That's common CSV data, comma separated value data, right? Like in your homework. How can I get each one of those things? Each one of those things, there are 4 of them. What are they called? Tokens, right? String tokenization. I want to chop it up along all of those commas. Right? Well, if I was to C, I would use strtoc, tokenization. Every language has some way of processing CSV data. If you were to do CSV data in real life, bring in a library to do it for you. That's the answer to most things anyway. But if you want to split this up into its components, into its 4 things, then there is a nice split function. Split it along commas. This, well, okay, that'll split it. What does it return? Again, let's read the documentation. Split. It returns a string, just one string? No, it returns an array of strings. Dirty old arrays. String tokens is equal to, and then it's an array. So there we go. And then I can look at each one of these tokens. So system.out.println. Let's print the first token. Tokens of 0. The second token. The third, the fourth. Lots of copy pasta here. Good idea, bad idea. Bad idea. Copy pasta gets you spaghetti code. Right? Don't do that. Instead, look for a better way. Even though it works, Chris, Burke, 1, 2, 3, 4, Shore 105. You'll note that the commas here are gone. It took out the delimiters, threw them away, and only gave me the tokens. Right? Okay, well, I don't want to do that. I just want to print it out to see what it looks like. Right? Let's write some less code, fewer lines of code. System.out.println tokens. That's the trick that I used with dynamic collections with a list, a set, a map. All those things worked out for me, didn't they? Let's see if this works out for me. Garbage. What do you think that is, by the way? Java.lang.string. That's the type. This, I think that this is telling me that it's part of the language. And then what's this gobbledygook right there? What's that garbage? It's a hex string, definitely. If I run it again, well, should it be the same thing? It looks like it is. It looks like it is. That's because it's a Java virtual machine doing the same thing over and over again. What is it? I heard it. It's the location. It's the memory address at which that array is stored. Right? But I really want it to print out in a human-readable fashion. Well, is there anything that will help me? Oh, of course, you could go to Stack Overflow or something. Print Java array, nice formatting, whatever. How to format an array with printf in Java. Okay, that's going to be not exactly what I want. I want to print a formatted array. So he's got like a 50-line solution here. Is there a better way? Is there a better way? Okay, I'm not going to get an answer here, so I'll just give you the answer. There is a nice arrays.toString, and you give it any array that you want, and it deep toString. ToString tokens. There we go. And it'll print out a nicely formatted, comma-delimited array with square brackets around it, and there's no comma at the end. So yay, right? If I just want to print it out and I don't care about the formatting, I can use arrays.toString. And guess what? Arrays, Java, arrays. There are a whole, not the tutorial there, but I want the Java doc. Wow, there we go. Arrays. There are, again, dozens and dozens and dozens of methods that will allow me to do bulk operations on arrays. Right? Great. All right. More on strings. What else? What's one operation that hey, I know how to do that in C. I know how to do that in Java or C++ or something, or JavaScript or C or Python or something like that. What's another thing that you'd want to do with strings? Say what? Oh, comparing strings. How did we do that last week? Like compare to. It returns an integer, something negative if they're in order, apple and banana. Something negative if they're out of order, banana and apple. And 0 if they're in order. All right. If you think of anything, let me know and we'll do it up here. All right. But otherwise, again, RTM. Just RTM. Read the manual. Right? The question again, the what do you do in problem solving? What do you do in engineering when you've got a problem? And the first question that you should ask yourself is, yeah, is it already solved? Did somebody already do the work for me? Right? That's the whole reason that we code to begin with. Right? We code so that we automate solutions. And if a solution is already out there, that's not cheating. That's using, I know, code copying in this course is of course cheating, but reusing library code, that's perfectly fine. Anything that is in the Java SDK, use it, right? And use it freely without worry of plagiarism or anything like that. Right? There's an alternative here. So again, strings are immutable, but you can use string builder to get a mutable string. Right? So I really like changing my strings for some reason, right? Well, fine. You can go ahead and change your string as long as it's a string builder. And there's also another version of this. I forget what it's called. String what? String buffer, I think it is. Yeah, maybe another one too, but I'm not sure. I'll just call it SB is equal to new string builder. SB is mutable. You can change it. SB.append, right? Chris. Right? And SB.append again, a space Burke. Right? There we go. And if you ever actually want to print it out, you can go ahead and print it out and see that Chris Burke is there. I'll go ahead and change it again. PhD, I guess. There we go. I'll go ahead and append. I don't want to append Burke again. I'll go ahead and append comma PhD. Right? I meant to start with my middle name, and then I need to print it out again, of course. And you can see that it's actually changed. Right? Then it's different. Right? Let me go ahead and now, what if I want to include my middle name in there? Ooh, that's a good question. Dot insert. There we go. You can insert in the middle of stuff. CHRIS space. So insert at 5, the string space, Michael, and then another space. And then let's see if that worked, or if my math was off, my arithmetic was off. Nope, good. Oh, except that there was already a space in there, so I don't need that second space. So I'm going to go ahead and magically take these strings, push them to the side so that I can fit this other string in there. I can do that because it's mutable, it's changeable, and it's a string builder. Right? If eventually you need to dump it to an immutable string full name equals, you can always go sb.toString, right, and dump it. Now after this point, of course, full name is going to be immutable. You can't change it. Right? But you can always go back and change string builder if you want to. Right? So there's an example of a mutable version of a string. Now, just in case you think, oh well, why I like mutable strings, why don't we just always use string builder? Actually, strings, immutable objects, are much better than mutable objects because they give you thread safety automatically. If you have the guarantee that you've got two independent threads that are reading the same data, and you've got a guarantee that the first one cannot change it and pull the rug out from the second one, that gives you thread safety for free. Right? And all of the built-in types, integer, capital I integer, big D double, string, all of those built-in types are usually immutable. In general, you want to prefer immutable objects because of thread safety. Right? All right. Let's see. Jump ahead, or let's see what time. Okay. All right. Well, implicitly the entire time we've been using methods. Let's go ahead and write our own methods now. So Java, in Java, functions are called methods, right? Don't worry about the pedantic difference. There is a technical difference between functions, methods, routines, subroutines, algorithms. You can list everything that's basically the same thing. A routine for a list of commands for doing something, and you can come up with a different name in a slightly different context. They're called methods because they belong to a class. In C, we didn't have classes. If you created a method by default, it's just going to be hoisted up to the global scope. SQRT, right? That is a global method function that anybody can use anywhere as long as they bring in the math library. But in Java, everything is a class or belongs to a class. So we can't just have this function sitting out in the ether. It has to belong to some class. Well, if there's that slight little bit of a difference, we need a new name for it, and that's why we call it methods. Right? They're just functions. Don't worry about it. Right? In Java, for now, I'll say, for now, all our methods will be static methods, meaning the methods belong to the class and not to instances of the class. Later on, we'll talk about instance methods, virtual methods, whatever you want to call them. But for now, we're just going to use static methods, right? You can access, invoke, run static methods using the class name plus a dot plus the method name plus any parameters you want to pass to it. All right. So again, I'm just going to go over to my IDE here. And let's go ahead and create one method that you see immediately is what? The method that we've been using and defining so far is the main method. If you've got a main method, that means that you've got that class is runnable. That you can actually hit the play button up here and it'll run. If I didn't call it main, if I called it secondary, right? There's no main method anymore in this class. This is no longer a runnable class. If I go up here and hit play, there is no main method. It's not going to run, right? Because only a main method can actually be invoked from the Java virtual machine, right? So I'll go ahead and restore that. Let's make some other methods here. Give me a method, simple. Give me something you want to compute. Public, static, anything? Okay. Square, area. That's kind of too simple, right? That's going to be what? If I pass in, it's a square, so it's just going to be one thing. So x times x, I'm going to return x. Don't write a method like that ever. Yeah. Oh, okay. Static factorial, right? Int n. Good. And I will return an integer. This is my first attempt, right? We're going to come back and we're going to change this because I like big numbers, right? And factorials become very big very quickly, and I'm quickly going to overflow x here, right? So there's my first declaration. Let's walk through this. Public means that anybody can see this method. Anybody can use this method. If I were building my own math class, which I seem to be doing right now, then having it be private, which is the other one other keyword, that means nobody can invoke it, nobody can use it. It's no longer a library function, right? So I'm going to make it public so that everybody can see it. Static, just because I said that's what we're going to do for now. It belongs to the class. What's its return type? It's going to return an integer. Its name is factorial, and it takes one parameter int n. Right? Let's go ahead and use it down here. Well, I guess let's implement it first. All right? Help me out. Factorial. So if you're not familiar with factorial, it's the perfect bad example for a lot of stuff. Then what is it? Well, it's n factorial, exclamation point. It's simply just n times n minus 1 times n minus 2 times n minus 3. Or if you want to read it right to left, it's 1 times 2 times 3 times 4 all the way up to n. An example, 5 factorial is going to be 120 because that's 5 times 4 times 3 times 2 times 1. Okay? So that immediately suggests a way of computing this. Help me out. The mod would be division. And if it gets too big, you might want to keep it small. And so you could use mod in some capacity. But what I want to do is I want to go 1 times 2 times 3 times 4 times 5 all the way up to n. A simple for loop. For int I equals, should I start at 0? Okay. Why? If I started at 0 and I 0 times this, then what? I'm at 0 and I stay at 0 forever. I is equal to 0, I is equal to 1. I is less than or equal to n. I do want to go up to n and include it, I plus plus. All right? I'm going to need a temporary variable here. I'll call it result. Let me leave it like that. All right? Result is equal to result times I. Right? Now, as I go through this loop, it's going to be result is times 1, result, now that's put into result, times 2, put into result, times 3, put into result, all the way up to and including n. Right? Obviously, it's not letting me do that yet. Why? It's complaining. Let me hover over it and find out what the compiler error is. If you can't read that small, the local variable result may not have been initialized. Wait a second, I thought that Java had default values. If you create an array, the default value is a bunch of zeros, right? But if you create a local variable like this, there is no default value. But unlike C, where it's, go ahead and roll the dice and see what you get, the compiler complains about it and says you can't do that. You have to initialize result. Should I initialize it to 0? What should I start it at? 1, so that it's 1 times 1 times 2 times 3 times 4. That suggests that I don't have to start at 1. I could start where? 2. Okay. That looks good for now. Int n is equal to, well, from the Wikipedia version, let's go ahead and go with 5. What's the result of that? Factorial is equal to, I'll go ahead and go with fact here, is equal to, how do I call that function? That function, that method, excuse me, that method belongs to a class. So I need to invoke it from the class name, demo, dot, factorial, and then I need to pass in the value, and I get that. So class name, dot, and then the function name. You'll see here that it's even italicizing it. That's telling me that it's a static method here that you can invoke by using the class name and then this. Let's go ahead and print it out. System.out.printout. Now let's go printf. %d factorial is equal to %d and the line. And so this will be n and then fact. There we go. Let's run this. 5 factorial is 120. Excellent. All right. Awesome. What should 6 factorial be? What's 120 times 6? 720. Okay. Anybody know what 10 factorial is? Okay, good. 3 million something. I'll trust you. All right. What about, I don't know, 100 factorial? Run it. 0. Is that correct? Okay. Why? I heard it before. Overflow. But also, what about -10? What's -10 factorial? I don't know. 1? Is that correct? No, it's undefined. So 2 things that we're going to take care of on Thursday is I really want to know what 100 factorial is. So we're going to use what we how did we get big numbers? Big decimal or big integer. These are integers, so we're going to want to do that. And then also some error handling. How do we handle when somebody gives us bad input? Okay? All right, next time.